If the 5 cards shown above are placed in a row, like they are right here, so that cards B and C must be next to each other, like they are here, how many different arrangements are possible? The trick, and I do mean trick, this is the kind of problem that if you've never seen it before, it's extremely challenging. If you've seen a similar problem, it gets more and more familiar. I think there's some connection between this one and remember on our practice yesterday, the 2 boys and 6 girls seated at a circular table and the boys have to sit next to each other. I think there's some connection here. I'm not going to approach it that way, but there's definitely a similarity. I would think of this, just think of these 2 cards as like stuck together as one card. Because, like for example, the B and C might be here, right, in the first 2 positions, and then the other 3 cards, the A, the D, and the E, in any arrangement. Or you might have a random card first, and then the B and the C together here, followed by 2 other of the other remaining 3 cards. Or you could have 2 cards, 2 single cards, and then the 2 B and C together, followed by the final card. Or you could have the B and C at the end. And you have to ask yourself, for each one of these possibilities, how many ways could these 3 cards be arranged? They could be arranged in 3 factorial ways. 3 times 2 times 1, which is 6. So there's 6 ways this can happen, 6 ways this can happen, 6 ways this can happen, and 6 ways this can happen. I just realized I haven't told you the answer yet. The answer is 48 for 5, and the answer for 6 is 9. And you might say, wait a minute, 6 plus 6 plus 6 plus 6 is 4 sixes, that's 24. Yes, but this BC being together, like we said, could happen 2 ways, right? It could be BC or CB. So we need to then double the 24 to get 48. It's pretty tricky. It's pretty tough. Okay, problem 6, we have set A, which is composed of the elements. We see the braces for set notation, 0, 1, 2, and 3. Whole numbers less than 4. Or whole numbers less than or equal to 3. And then in set B, we have the counting numbers 4, 5, and 6 making up set B. If A is any element from set A, and B is any element from set B, how many different values are possible for the ratio of A to B, or that fraction A to B? All right, you need a tree diagram for this one. A could be 1, no, could be 1, but let's go on. Could be 0, 1, 2, or 3. B, once you've chosen A, if A is 0, B could be 4, 5, or 6. If you choose the element 1 from set A, B could be 4, 5, or 6. If you choose 2 from set A, B could be 4, 5, or 6. If you choose 3 from set A, B could be 4, 5, or 6. Sometimes you need the entire sample space to answer the question. This is one of those times because some of these values, A over B, will be the same. Like right away, 0 over 4, 0 divided by 4 is 0. So is 0 over 5. So is 0 over 6. So while it appears that we have 3 possible outcomes, since we're considering the values, these are not 0 divided by 6 is 0, not 1, sorry. There are not 3 different values. There's only one value possible if A is 0. So let's consider these other possible values of A over B. This would be a 4th, this would be 1/5, and this would be 1/6. Those are 3 distinct values. 2 over 4 is 1/2, but we haven't seen 1/2 yet, so that's another distinct value, as is 2/5. 2/6 it simplifies to 1/3, and we haven't seen 1/3 yet, So that's another distinct value. 3/4, 3/4 is a distinct value. 3/5 we have not had a value that's equivalent to 3/5 yet. However, 3/6 is 1/2, and we do have that 1/2 occurring in a previous possible outcome. So let me with red circle the distinct or different values. 0, 1/4, 1/5, 1/6, 1/2, 2/5, 1/3, 3/4, and 3/5. I'm not going to circle 1/2 because I've already circled 1/2. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9 different values. So there's the answer, 9. That was a tough assignment, but fun, challenging, interesting. I hope you feel the same. Have a nice weekend. I'll talk to you on Monday.